Hello everyone, I am Charumadi from EC department. In this video, we are going to discuss about two questions. And the first question is the comparison between the noisy channel and noiseless channel. In the second question, we are going to discuss about different wired LANs. Now move on to the first slide. In this slide, we are going to learn about what is protocol and its classification. A protocol is a set of rules by using which the two devices can communicate with each other. These set of rules are usually decided by the headers. These headers specify the content of the message and the way this message is processed. Protocols are classified into two types, noiseless channel and noisy channel. And the noiseless channel is further classified into two types, simplest protocol and stop and wait protocol. And the noisy channel is further classified into three types, stop and wait ARQ, go back and ARQ, selective repeat ARQ. Moving on to the next slide. In this, we can discuss about the noiseless channel and its types. A noiseless channel is an idealistic channel in which there is no frames that are lost or corrupted or duplicated. So there is no need for error control in this method. A simplest protocol. In this protocol, there is no flow control and neither nor an error control. It is basically a unidirectional in which the data frames are travel in only one direction, that is from the sender to the receiver. So the receiver immediately handle the frame it receives, and the frames that transmitted has very small processing time and that can be negligible. And the next slide, we are going to discuss about stop and wait protocol. Stop and wait protocol is a data link layer protocol and it also provides a unidirectional data transmission. And here there is only flow control facilities and there is no error control facilities. That is, after transmitting one frame, the sender waits for an acknowledgement from the receiver before transmitting the next frame. So the receiver receives and consumes the data packet, and after consuming the data packet, acknowledgement need to be sent to the sender side. That is, this is known as flow control. And there are some problems that are caused by the stop and wait protocol, and they are the problems due to the lost data, problems due to lost acknowledgement, problems due to delayed data or delayed acknowledgement. And in the next slide, we are going to discuss about the noisy channel and its types. Noisy channel protocols are commonly known as communication protocols. They are designed in such a way to ensure the reliable data transmission in a channel where the channel have a high probability of error loss or data loss. The example of the noisy channel is an automatic repeat request, that is ARQ protocol, which is used in the network protocols such as TCP. And the first type of the noisy channel protocol is a stop and wait ARQ protocol. And the idea of this protocol is straightforward. That is, from after transmitting one frame, the sender waits for an acknowledgement before transmitting the next frame. And the acknowledgement does not arrive in a certain period of time. When the sender does not receive an acknowledgement in a certain period of time, the sender timer expires and it retransmits the original plane. That is, it offers error control and also the flow control. It has very low efficiency and it can be improved by increasing the window size. And it detects errors in the transmitted data by using measures such as checksums or cyclic redundancy checks, that is known as CRC. And moving on to the next slide, we can now discuss about go back and ARQ protocol. Go back and ARQ uses the concept of protocol pipelining. Pipelining means the sender can send multiple frames before receiving the acknowledgement for the first frame. There are finite number of frames in the sender side and these frames are numbered in a sequential manner, that is as 1, 2, 3 and goes on. The number of frames that can be sent depends on the window size of the sender. If the acknowledgement of the frame is not received within agreed in a certain period of time, all frames in the current windows are retransmitted. That is, if the acknowledgement for one frame is not received, The sender has to send the whole frames and retransmit the whole frames. The size of the sending window determines the sequence of the outbound frames. Now moving on to the next slide. Let us discuss about selective repeat ARQ protocol. In selective repeat ARQ, only the lost frames are retransmitted while the correct frames are received and buffered. And here there is no need for retransmitting the whole frames. So the receiver, while keeping the track of sequence numbers, buffers the frequency in memory and sends the NAC, that is no acknowledgement, for only the frame which is missing or damaged. So the sender will retransmit the packet which receives the NAC acknowledgement. That's all about protocols. Now move on to the next question, that is different wired LANs. There are 6 types of wired LANs that we are going to discuss, and the first one is Ethernet LAN. The Ethernet LAN is the most widely used wired LAN technology. It uses Ethernet cables and the name itself. And it uses Ethernet cables and switches to connected devices in a local area network. These Ethernet LANs typically follow the IEEE 802.3 standard, and it helps us provide high speed data transmission. And the second type is token ring LAN. Token ring LAN is an older LAN technology where devices are connected in a form of ring, that is ring topology. Data is passed sequentially from one device to the next using a token. Here the token plays a major role. It was popular in the past but has largely replaced by the Ethernet in the nowadays. And the next type is fiber distributed data interference, that is FDDI. The FDDI uses the fiber optic cables to create a high speed LAN, and it contains 2 token rings, that is the primary and the secondary. It is known for its high reliability and redundancy features, making it suitable to critical applications. It offers a high transmission capacity, that is up to 250 gigabits per second, and it can handle information rate up to 100 megabits per second. And the fourth type is the attached resource computer network LAN, and it is often known as ARCnet LAN. And the ARCnet LAN is a central token passing LAN topology. It uses a token passing protocol and coaxial cables to connect the devices. And it is simple, and also it is low cost and easy to install. But it has a low speed compared to the Ethernet. Now moving on to the next slide, we now discuss about asynchronous transfer mode LAN. Asynchronous transfer mode ATM LANs uses cell switching technology to transmit the data over the fiber optic or a twisted pair cables. While it is capable of very high speed data transmission, it is more complex and expensive. So it is used to transfer all the services like voice, data or video and etc. And the last slide is the powerline LAN. Powerline LAN uses the electrical wiring for networking and the name itself. Devices communicate through electrical outlets, providing a wired network without the need of the additional cables. There is no need for the additional cables. We can communicate through the electrical outlets with use of the existing cables. And each of these LAN types has its own advantages and disadvantages, making them suitable for different scenarios and environments. And that's all about the video. Thank you.